good evening and welcome to the class. It's a new semester and this is going to be Energy System Lab 2 and this is the first lab. Please check the Blackboard for the class time hangout and check out the material for this week content, which is Lab 1. And in this week, we will start by doing some basic wiring for a CAD primary control. Why is it called a CAD primary control? Because it uses a CAD cell to detect light. What's a CAD cell? It's what you have in the night light. It's a small little cell that changes resistance based on the light. Based on the photons in the light, it's called CAD because it has cadmium sulfide in it. So now you know what it's called, CAD primary control. The name, usually they call it the primary control, sometimes they call it the CAD control. So you know where the name came from. The main purpose of this control is to monitor and operate your oil burner. It's also used for gas, something similar used for gas. So it should be fun, and we will wire this CAD control at least 5 times. So don't feel concerned if you didn't get it very well the first time. It will get better as we do it over and over again. But the function of this CAD is very, very important. And they have came through, I think this is the 4th or 5th generation of CAD primary controls by Honeywell. The first ones came in the 60s, even earlier than that, and they have more sophistication now and more controls. The most recent one has an LCD screen that tells you actually what's happening. So if you can take one or two things from this lab is how to wire properly a CAD control and an aquastat, and we'll go through that a little bit in a lot of details, and we get some hands-on practice, and you'll see how it's a little bit complicated to just talk about it without looking at it and doing it in the lab. Okay, let's start. So the objective again to properly wire a CAD control for residential oil burner. We follow the sequence of operation to see how it functions and troubleshoot the wiring problems. Why is it not working? What's the problem? And again, you'll see a lot of things can go wrong, and we can see also what is it going safety. How do we reset it? And they do go bad, but not that often. So I have few videos here that I'm not going to play during this recording, so you can go and look at the PowerPoint and play these videos. They are about basic wiring techniques. If you did not get exposed to those in the first semester, which is Energy System Lab 1, I did go over them, but it's a little bit important and it's good to go over them. They're very short. So wire gauges, how do they difference, what amperage goes with what wire. It's very essential to know these little details. Short circuit, what's a short circuit? What get activated when you have a short circuit? Safety and testing, and how do you wire middle of the run receptacles? And I think the main reason I put that in there is to realize how receptacles are wired in parallel in a household, and how do you do that in the right way. Electrical tape, which tape do you use and when and why. We do not like to use wire tapes, I mean electrical tapes, but we like to use wire nuts. AFCI is different than GFCI. It's good to know what is the difference and what is the function and when do you need one. Okay, so the primary CAD cell control, it provides timing and sequence of operation for oil and gas burners. Because think about it, you need the element of combustion, you need air, you need fuel, you need ignition. So you need to time these properly, and you're dealing with very combustible fuels. So you want things to be done properly with the least amount of problems, and you also want to ensure the safety that these things are happening in the right time and the right amount. Well, it's okay. I'm trying to adjust the light here to get the best lighting possible. Oh well, we'll do with this. Anyways, so the input, every control needs input and output, right? So the input that this control is getting is from the thermostat, which tells the control that heat is needed or we had enough heat. So that's one input. Second input is the flame. Do we have flame or there is no flame? And that's the FF terminal coming from the CAD cell. So these are the two inputs. The output, the CAD control, or the primary control, will determine which runs and for how long. We have the motor, ignition, and valve. So we have three outputs coming out of this control. The control needs also electricity. So it will need a line voltage, which is 110, and neutral, of course, to complete the circuit. And it needs to have a transformer because it's sending signals to the thermostat, which is, hold on, sorry. Thermostat is usually operating with 24 volts. So this is 24. Okay, so but the input coming in is 110. So all these here require 110 volt, and this is 24 volt for the thermostat. So we need to have a transformer. So keep that in mind. I will keep asking you this as we go along. This is the schematic for the primary control, and we talked about how it looks a little bit overwhelming in the beginning, but if you eliminate all the stuff from the inside, you didn't look at it, and you look at the wire coming out. So this is called a three-wire thermostat, meaning it has black, which is power coming in, that's line voltage, and it has white, that's to complete the circuit, and orange. The orange wire, in this case, controls everything. So everything comes in together. That's completely inefficient, and this has been phased out 3 years ago. We no longer install these in houses, but if they are there, they are grandfathered in. And for new installs, you need to get something with different timing. Again, these had really uh, basic operation, and they have what's called constant ignition. So ignition is coming all the time. So you're gonna have the oil valve open all the time, the burner motor, and the ignition is completely low efficiency. And we see we have this our two inputs here, thermostat and CAD cell. Take a minute to look at this a little bit and look at the notebook for wiring. So this is the old one, but they did evolve way much further than it was. So now we have, instead of orange, we have three different wires, and we have something called intermittent ignition, which means it stops. I mean, intermittent actually, it means it's constant. It's kind of counterintuitive. They have, now we have interrupted ignition, which means the ignition will come in, and as soon as we prove the fire using the CAD cell, we will drop our ignition. So it doesn't have to stay on all the time. It comes on, then it goes out. So some important tips. Again, I don't want to talk about it too much. I want you to go and experience that. But it will be nice if you go over this beforehand and get an idea. So when we go into the lab, you can see how these things do take place. So first of all, we need to use the proper wire size, which is 14 gauge. That's the size, 14 gauge. And we use wire nut properly, make sure everything is sound and connected properly, because in real life, you will have all this wiring behind the control, and you're going to squish it into a junction box and tighten it. So you don't want anything to break loose, and you want to cut the wires properly. You don't want to be too long. So again, try to make it as neat as possible. This will help you do some kind of troubleshooting later on. We'll be using 310 light bulbs instead of the motor, ignition, and oil valve, because we want to do everything on a board using light bulbs instead of actual equipment. Why is that? Because I will love for you to learn how does it function first before we engage with wiring live equipment with oil and ignition and fire. So this will make things a little bit easier. So 110 for 110 light bulbs for three components. 24 volts going to a dial thermostat. So we will wire one thermostat, and we have our CAD cell, which has the yellow wires coming out of the control. So make sure you have all these handy with you. And for the boards, I have replaced the connections. Instead of having a screw connection, there's clips to make things a little bit easier, so you can focus mainly on where the wire goes instead of putting screws into wires. So follow the sequence of operation and record the safety timing. What is the safety timing? It's the time when the control shuts off if there is no fire. Why? Because we do not want to keep dumping oil into the chamber when there is no ignition. So the safety time used to be 45 seconds. That was in 2015. It got reduced to 30 seconds in 2016, and now it's 15 seconds. Why? Because we have more technology now and we can do it. We can do better. So 15 seconds is the new safety timing in Massachusetts. It could be more somewhere else. And if you think about it, that's enough time to activate fire. What happens? So 15 seconds, no fire, will shut off. We'll wait for 30 seconds and the system will try again. It will shut off if there is no fire, and we'll try a third time. Then it will go into a hard lockout, meaning it's not going to try again. Somebody has to go and check what's going on. So there's possibility for error, but it will try again. If you have a car starter, remote car starter, it does the same thing. It will try 3 times to ignite the car, turn on the car. If it doesn't, it will shut off. It means if you try 3 times and things don't work, something is not working properly. This is the sequence of operation. That's what happens. So the primary controller is already wired. It's already having power, and it's just on standby. The red wire, there's in the new ones there is a red wire which is called the limit. This limit is basically telling the primary control to turn on. So even though it's wired on standby, this limit tells it, okay, it's time for you to call for heat. And it's used also in conjunction with Aquastat. So when we in the lab, I will show you the equipment and you can look at it, and it's good to see it when it works. There's a red wire that's supposed to tell it to turn on beside the thermostat. We'll talk about it later. I don't want to confuse you right now. And so the primary is on standby until the thermostat calls for heat. So both red wire and black wire, they have power, 110 volts. Thermostat closes the circuit and we can call for heat. Then the primary control PC will check for the fire. So it doesn't turn on, it does not turn on right away. It will check if there's fire in the chamber. How does it do that? It will check the voltage coming or the resistance coming from the CAD cell control. The CAD cell, which actually looks like a receptacle, in the dark it has very high resistance, almost 10,000. Sometimes actually it's over 10,000. So when the resistance is high, I mean it's dark. So it will give the okay to start the primary. If the resistance is low, it's not going to start because it will think that there is fire in the chamber. So if there is no fire, it will start and we'll get it will start the motor and the ignition, and in 15 seconds it will start the oil valve, which means oil will come in just to make sure that there is ignition and there's air coming in, and we can start the oil valve so to open up the passage for oil to go through the nozzle and spray, and we have ignition. So then the fire will start and the CAD cell will have low resistance because again now it's seeing the light, and that means okay, we have fire, we have achieved ignition. It will drop the oil valve, and you can see that when we look at it connected in the board. Ignition will drop and it will remain on until something tells the primary to turn off, which in this case is going to be the thermostat. It will get satisfied, it will open the TT terminal, and meaning we have enough heat, so it will shut everything off. So I know it sounds a little bit overwhelming, but think about that, read it a little bit, and once you see it actually in action, it will make logical sense. And try to imagine the primary controlling the burner and what it's doing in steps to get that done. This is again the operation of different primary control. This one for the Rielos, it's the European type, it's the same. And this is actually a picture from your notebook which has all of the information you might need about oil burners. This is the third generation primary control from Honeywell. It has also the schematic in here. We will use some of these, but I'm using the most recent one, which actually has an LCD screen that tells you what's happening. Okay, so I know it's a lot of information. Please try to look at the video and look at the PowerPoint, and it will make a lot of sense when you do it in person in the lab. And please come with some questions. And for this lab, I'll need you to have your goggles on, your gloves, and a lot of patience. Okay, see you soon, and good luck.